Okay, number 1. All right, you ready for number 1? It says the measures. Now, people, we're talking about Theorem 6.1. Okay, can I get that straight with you? This is Theorem 6.1. I'm spending our time on. And Theorem 6.1 says the sum of the measures of the interior angles of a quadrilateral is what? So the first three problems is dealing with Theorem 6.1. You clear? Okay, so here we go. Number 1 says the measure of 3 angles of the quadrilateral are 80, 90, and 103. Okay? And we add all of that up. Help me out. Don't make me look bad here now. I got 273. It's the sum of those 3. But what is the sum of all 4 of them?
360.
Well, if 3 of them is 273, then what will be the answer to the next one?
365.
All right, bar 1, 8. I got 87. Did y'all get 87? Now, people, on your next test, that question will be there. Now, those numbers won't. I'm sorry. Those numbers are going to change. One of them is going to increase, and some of them are going to decrease. But that's how you do number 1. You clear? All right, let's go to number 2. Now, on number 2, we're going back to that ratio bit. You remember how I told you that? You got angle 1. How many angles does a quadrilateral have? And then the ratio. I had people putting 8 plus. It's not 8 plus, it's what? 8 times. So what is it? 15 times. And then what's the last one? Now, what do you know about the sum of the measures of the angles of a quadrilateral? So how many x's do we have? Let's see. Well, how did y'all get that 3 to come 4? All right, how many? 9 and 5. Let's see, that's 14.
72.
Thank you, sir. Now, what should that equal? All those x's should equal to the sum of the measures of the angles of a quadrilateral, which is what? 360. Divide by 72. So x is what? 5. Well, then what's 5 x's? No, what's 8 fives? What's 15 fives? What's 21 fives? And then what's 28 fives? Is that 140?
Yes, sir.
And that's number 3. Can you handle it? On your next test, that is on there. You got it? And this is number 3. Okay. Let's go to number 3. I wish I had room to put that on this board, but I'll have to do another one. Number 3. Okay, the 4 angles of a convex quadrilateral. How many sides does a quadrilateral have? Then that means you have how many angles? All right, is this the length of the sides or the measure of the angles? 3x minus 19. Is that the length of a side or is that the measure of an angle? Come on. Look, it says 4 angles. Okay. So write them all down. All right. Angle 3. And then angle 4. I messed up a while ago and put 3 twice. Well, we got it straight this time. Now, young people, I could stretch these out, or I can just go ahead and add these up in this column. So they got 3 and 6, and see, that's what, 9? Is that 15 x's? Now that's 10. 10 is 26. Is that 45? Huh? Now what is that equal to? 360. Now just for curiosity's sake, what if that was been a pentagon? What would they equal? You know, forgot?
Wait.
I thought maybe I remembered that now. I thought maybe I remembered it. Okay, that's no problem. All right. So what do we do next to get x by itself? 2, 4. So well, let's see, people. That's going to be 405 divided by 15. All right. I'm waiting. 27. Okay, help me out here now. What's 6? 27 3 times, take away 19. 3 27s, take away 19. How many twos?
62.
All right. What's 6 27s, take away 10? 152. All right, what's 4 27s, take away 10? And then the last one is 54, take away 6, 48. And young people, there's the first 3 questions. Can y'all handle those? Those are the first 3 questions on your next test. Now that's Theorem 6.1 now. That covers Theorem 6.1. Everybody clear? Theorem 6.1 says the sum of the measures of the angles of a quadrilateral is 360. And those are the 3 questions that I'm kind of bringing out for you to learn it. Now, everything else now is related to the polygon, the regular polygon. Now, people, are you up on what I'm saying by convex? I've been thinking about trying to say, how can I help people? For instance, on this this right here, say you had a box. Okay, that's not a perfect box, but anyway, it's a box. Now that's convex. That box is convex, but he's not a perfect unit. He's not 90, 90, 90. He's not regular, but he's convex. A convex, being not a convex, is like somebody come in there and see that trash can. I always got a tin one in there, and they kick it. Okay, they kick it can. And so, let's see if I can do better than that. So they kind of like take this can and they kick it. Now, they got it bent in. You got it? Well, then he's no longer convex. You done messed my can. There's no words convex. Convex does not bend in. Now, we call this a concave. You ever heard somebody says the cave caved in?
Yes, sir.
Well, that's what concave is, that they bend in. So if I took let me do this. If I took a straight edge and I went down this line right here. Oh, come on, man. And I went down this side. But what happened is it got inside of that's not convex. So a convex is nobody's kicked it in, bent it in, as you might say. So that's not convex. A convex means you go down one side, you don't touch the other side. You're like a boundary. There are boundaries. Okay? All right, well, I hope you caught on to that. That's what convex means. Now, we're talking convex, so no dents in it, perfect, and we're talking regular. Okay? Everything now is going to be regular. Okay, what that means is that all the sides are going to be the same length, and all the angles are what? The same length. But young people, at no time Am I going to ask you about a length of a side? It's all angles. All angles. Okay? I asked you to write a while ago, what would be the formula for finding the sum of the measures of the interior angles? I hope that you wrote SUM equals n minus 2 times 180 or something like that. You could have said this and I would have accepted. In other words, you didn't have to put the X. Did anybody do that like that? Okay. I hope you know that. Now that's what we're going to study now. Okay? We're going to study that. Now the other question I ask you is, what was the sum of the measures of the exterior angles, 1 at each vertex? I'm hoping that y'all put the sum is equal to what? 360. Now people, that's what our next line of questions relate to. You got it?
Oh, yeah.
Everything else is kind of see how we can incorporate that into our system. So number 4 says find the sum of the measures of the angles, and I got 4 different ABCs. So the first one is we'll find the sum of the measures of the quadrilateral. So here we go. What formula are we going to use? This. Now, n is 2 things really: number of angles and number of sides. Okay, because it's regular. So that's number. That n stands for either way you want to say it. Okay. So when I say a quadrilateral, I may ask you how many sides does it have, and you what I'm expecting you to say 4. So n is 4. Take away 2. So 2 times 180 is what? So that's number 1. What? 8. Can you handle it? What's number 1b? Decagon. Okay? So you write the formula. Now, I will say this, that sometimes people say, I'm tired of writing that formula, I just know it. Well, till you really know it at that point, I'd write it every time. So the sum is equal to how many sides does a decagon have? So we got 10, take away 2 times 180, that's 8 times 180. Okay, let's go with what? 1440? And that's number 1b. I'm not doing 2b. I'm not doing 1c and 1d. Guess who's doing those? You all.
Yes.
All right, we're going to number 5. Now, people, number 5 is a, I don't know if it's using a formula so much. Well, I guess you could say it is. It says each of the 5 angles of a convex hexagon has measure of 130. Now, this is a hexagon. Now, I know you don't have the luxury to do what I have. I am very fortunate. I have this instrument that I can draw a hexagon. And I can go in there and tell you that angle's 130, that angle's 130, that one is, I can tell you that 5 of them is 130. I can tell you 5 of them. I can tell you 5 of them. But I want you to tell me that 6th one. Now, can you handle that chore? Is it too heavy for you to carry? Well, first of all, we have to know the sum of the measures of the angles of a hexagon. How much is all of them heavy? Well, you come over here and you say, now the hexagon is how many sides? 6, take away 2. So we multiply 4 times, 720. Now we got to multiply 130 times. How come I'm not multiplying it times 6? There's only 5. So what is 5 of 130s? 650? So how much is this last one going to have? I got 70. Do y'all have what I have, or is I got a number wrong?
Yeah, you got it.
I say it's 70. Well, how come he's not 180? Well, he just didn't have it. The rest of them took it off. Well, how come he's not 130, rather? Could you handle that problem? Okay, that's a thinker there. Boy, I'm going to tell you, you got to do some thinking on that one. No, Miss Law, please don't ask me to do a lot of thinking. Oh, I am. Oh, I am. Okay, number 6. What is the measure of one exterior angle of a regular convex polygon with the given, that's a lot of words. Can somebody decipher that for me one more time? What is the measure of an exterior angle of a regular convex polygon? Regular means they're all equal angular and equal what? Lateral. Convex means it doesn't have any what in it? No dents. Perfect. Perfect. No dents. Nothing caved in. I guess you could say it's not caved out, but most of the time you think it's caving in. Alright. With the given number of sides. Number 6. Now people, I'd like for you to see something here, and I'd like you to think a minute about something. It says 6 sides, so we know it's a hexagon, right? Okay, so I'm going to draw that just for a minute here. And then it says, what is the measure of one exterior angle? Now, if you would go back and recall, I told you if you take one side of a polygon or one side of the triangle and extend it out, what would you call that angle on the outside? Do you remember? What did I call that fellow? Exterior. Well, it hasn't changed, young people. He's still on the outside. Now, the inside would be this one right here. Now, I want you to visualize something. If I take the interior angle, get the word, and I add it to the exterior angle. Now, I'm cutting corners here. We're just putting these words here now. What should the measure of the interior angle plus the measure of the exterior angle equal to? Try again. Why? That's a linear pair. Yeah. Now watch now. This is cool move here now. If I subtract the word interior from both sides. Now I'm going to tell you something here now, young people. Subtracting the word is about like subtracting the number. It's gone. All right? So look what you got left. You've got exterior is equal to what? 180 minus what? Interior. So if I go to you and I say my interior angle is 100 degrees, what's the exterior angle?
80.
Yeah. So you can figure that out by doing what? I want you to see this though. Look. Interior. Guess what he's equal to? Take a guess. It'd have to be 180 minus exterior? Now let's see what we got here. So what is the measure of one exterior angle of a regular convex polygon with the given number of sides? Now, young people, Please tell me you know the answer. Come on. I want the answer from you. Is he the only one who knows the answer and he's sleeping, so you ain't gonna get it? He ain't awake to tell you. He's getting ready for the night. He'll be fired up. Huh? Y'all know that answer. Come on, tell it. Mick, help us out. I don't hear any response. He's still not going to tell us because he's still. Good morning, bright stars. Look at the sun shine. It's shining. Somebody in here's got to tell me. Come on. You're not going to the ball game until you tell me. You're not going to get any ice cream until you tell me.
What's the question? Yeah, get you to repeat the question.
All right. Now, when I said ice cream, we want to repeat the question. What is the measure of one exterior angle? That's the outside. Of a regular convex polygon with the given number of sides. That's 6 sides.
Do you do the n minus 2 times 180 and then divide it by the amount of sides? Yeah.
Now that would be the measure of the interior.
It's 360.
So then you do.
I love how mine's working. You're doing a wonderful job. Then what, babe?
Then you do interior angle plus x equals 180, and then subtract the interior from the 180, and you get your exterior. X equals.
Good job. Yep, she gets the ice cream. Y'all don't. Unless she says it's okay. No, young people. Well, let me follow up what she did. She said, why don't we find out what the sum of the interior angles are? Now, do y'all remember we used this formula? And that's what she said to use. So we know the sum is, now how many sides? 6 take away 2. Y'all with us? All right, so then what is the sum of all of them on the inside? Now, I will say this. We will be doing these pretty much this week, and you'll be surprised. You'll learn that the 5 is 540 and the 6 here is the 720. You'll be surprised. You'll start remembering that. Okay, now she said that's the sum of all of them. Now, we know there's how many angles in a hexagon? So if we take this number and divide by 6, we're going to get the measure of an interior angle, right? So if this interior is 120, she said, well, come over here and take 180 and subtract 60, and the answer is what? I'm sorry. I apologize. I was putting the answer. I do that too many times. So what's the exterior? 60. Now I was expecting you all to be able to figure that out. But I like to see if you like this approach. Okay, see if you like this approach. Or can't think about it. A while ago, I told you to skip 3 lines, and I asked you to tell me what is the sum of the measures of the exterior angles, 1 at each vertex.
360.
And so the sum of all of these guys, all of them, is what? 360. Now how many do you have? So if you took 360 and divided by 6, guess what the answer would be? The exterior. Alright, Dean. Now, boys, I'm going to tell you something. You're going to have to win it without me tonight.
Yes, sir.
I won't be there to cheer you on. But I'll tell you right now, those girls will do a good enough job.
Yeah.
They'll be out there hollering their voices off, freezing to death to make sure you do good.
Mr. Tommy, can I go through the office
Do you boys ever hear these girls hollering for you? You better say yes.
I block everything else.
No. That's why you don't do it well.
Once you start working, you come in here and we're in the red zone. It's not gonna be loud.
Yeah.